Hello everyone. Today we will discuss in lecture 4 of information theory and coding, basically entropy of binary memoryless source, extended source and relative entropy in this topic in this lecture. This is the syllabus. Till the last class we have covered within topic entropy of the source, that is average information of the source, properties of entropy, and in next today, that is we will discuss entropy of binary memoryless source and entropy of the extended source and relative entropy also. Properties of entropy we have discussed already. Basically there is a source which is a discrete memoryless source. It is producing some symbols at the output. Suppose this is source S with symbols S0, S1, S2 up to Sn minus 1. Suppose n symbols within that set and one can come at the output at a time. Okay. Then the discrete memoryless source have entropy H, it is already discussed, that is it is given as probability of each symbol, that is Pk, k is equal to 0 to n minus 1 and into Ik is the log of base 2 1 upon Pk. This is the entropy of the source S, and Pk is the probability of every symbols, that is k is equal to 0, P0 is the probability of symbol S0, P1 is the probability of symbol S1 at the output. So, that we can calculate the entropy of the source in this way, and this entropy as per the property we have discussed that this entropy is bounded in the region 0 to log of n base 2 basically. Okay. See that in this range this H will lie at P is equal to 1, entropy is 0, and it is maximum when the source is equiprobable, that is Pk equals to 1 upon n, and that we have proved that using the inequality, that is log of x less than equal to x minus 1. This inequality we have used to prove this property in the last lecture. Okay. Now, next is the entropy of the binary memoryless source. See binary memoryless source, then this is the source, binary memoryless source. It is a discrete memoryless source with S having only two symbols S0, S1. Okay. Only one comes at the output at a time. Okay. Normally we take binary symbols 0 and 1 as a symbol. Okay. S0 is 0, S1 is 1, we can take. Okay. And its probability, that is P0 and P1, P0 for S0, P1 for S1. Okay. Then we can calculate the entropy of this binary memoryless source with the condition that the symbol at the output they are coming and they are statistically independent with each other. Okay. So, H can be calculated as given in the last slide, that is k is equal to 0 to n minus 1 Pk log of base 2 1 upon Pk. Okay. Here n equals to 2. Then this is k is equal to 0 to n minus 1, that is 1 p k log base 2 1 upon p k. Okay. Here at k is equal to 0, this is p naught log base 2 1 upon p naught, and at k is equal to 1, this is p 1 log base 2 1 upon p 1. Okay. Here as we know that summation of probability that is k is equal to 0 to n minus 1 p k equals to 1. It means that is p naught plus p 1 equals to 1, then p 1 equals to 1 minus p naught. Okay. We can put here so that it becomes p naught log base 2 1 upon p naught plus p 1 is 1 minus p naught log base 2 1 minus p naught. Okay. This can be written as, because log of 1 upon p, that is the minus of log of p. So, this is minus p naught log base 2 1 upon p naught minus, similarly from here 1 minus p naught log base 2, sorry, this is p naught log of base 2 p naught, and this is log of base 2 1 minus p naught. Okay. This is the entropy equation for the binary memoryless source. Okay. We can plot the entropy function with respect to p naught, this is h. Okay. Then this equation, if we plot this equation, then this is point p naught equals to 0.5, this is p naught equals to 0, and this is p naught equals to 1.0. Okay. Then this plot as per bounded that is h bounded between 0 to log of n base 2, okay. Then 0 to h, n is 2 here, that is 1. So, h is bounded between 0 to 1. Okay. Now, its value is 1, suppose here. Okay. Now, the plot given like this one. Okay. Its value is maximum equals to 1 at p naught equals to 0.5. So, that p 1 equals to also 0.5, and then source becomes equivalent. When source become equivalent, its entropy is maximum. Okay. Its properties shows that entropy is maximum for equivalent source, that we can see, okay, through this plot. Okay. And it is entropy is 0 when p naught equals to 0. When p naught equals to 0, okay, the entropy is 0, and when p naught equals to 1, entropy is 0. Means that when p naught equals to 0, that is probability is 0, then entropy 0 means the uncertainty is 0. It means certainty is maximum at that point, because probability is 0, okay, then it is certain, okay, that is one symbol having probability 0, then other is most probable. Similarly, here when p naught equals to 1 here, then certainty is maximum here, okay, then uncertainty 0 here. Okay. This is the binary memoryless source and with its properties. Okay. Now, next is the entropy of the extended source. Okay. See, this is source, discrete memoryless source with S1 suppose, okay, and its entropy at the output, its entropy is H1 suppose, okay, whatever H1 value, k is equal to 0 to n minus 1 pk log base 2 1 upon pk. Okay. Now, if the similar source and which is also statistically independent, their symbol at the output they are producing independent with other symbols. Okay. Suppose there are two source, similar source. This is also a similar discrete memoryless source with same entropy H1 producing output one symbol at a time. Okay. See, suppose both sources are working, making it a single source. Okay. Then what happen? Okay. Suppose this is connected to a joint combined point and giving output here. Okay. Then what will be the entropy of this combined source which is statistically independent? Okay. See, suppose this source S1 having symbol, this is capital S, symbol S0, S1, S2, Sn minus 1. Other source that is also S1 equivalent to, we are treating it as capital S2, its symbols same S0, S1, S2, Sn minus 1 with the same probability distribution, P equals to P0, P1 up to Pn minus 1. Okay. Then here joint output you are getting the one, so you are getting symbol from source S1, then from source S2. Okay. Here you can get suppose here you are getting output S0, okay, and here you are also getting output S0, then it is a combined symbol S0 S0. Next S0 S1, that is a next possibility of the combined symbol. Okay. Similarly, S0 Sn minus 1, then S1 S0 S1 S1 up to S1 Sn minus 1. Okay. These are the possibility of the joint symbol. Okay. Similarly, Sn minus 1 S0 Sn minus 1 S1 up to Sn minus 1 Sn minus 1. Okay. These possibilities of the joint symbol, and because these are statistically independent, then what is the probability of the joint symbol? Okay. Suppose S0 S0. Okay. Because they are statistically independent, then its joint probability, okay, that is given as P0 P0, that is P0 square. Similarly, S0 S1, its joint probability is P0 P1. Okay. Similarly, Sj Sk, its joint probability Pj Pk, that we can calculate the probability of every joint symbol. Okay. Because this is a combined source, joint source you can say. Okay. Then you are getting a one symbol at the output in joint of the two source. Okay. And we can find their probabilities. Okay. Using these probabilities we can find the entropy of the joint source. Okay. Like that when their probabilities are calculated of every symbol, every joint symbol, then treating their probabilities at the single probability of that symbol. Okay. And for combined source, firstly we have to know about the number of symbols. Okay. Then for here, because we are taking only two sources, okay, then there are two positions. Okay. These two positions, first positions can be filled by n symbols, second position can be filled by n symbols. Okay. Then total n square joint symbols are possible for when we are taking two source at a time. Okay. Now, if you are taking more than two sources at a time, then what happen? If you are taking more than two sources at a time, okay, suppose this is the again a discrete memoryless source with the same symbols and same their probability distribution. Okay. Then combining the third, suppose this is the mth source. Okay. Then here there will be m position, okay, like that, this one x, y, z and so on, and up to mth. Okay. Then for mth position, at every position there is the n symbols are possible, then total n to the power m symbols are possible. Then for the extended source, total n to the power m symbols are possible, okay, like that, S naught, S naught, S naught and so on, S naught, S naught, S1, S naught, S naught, S2 and so on. Okay. Then for every joint symbol, we can calculate its probability, okay, using because they are statistically independent, then joint probability is the multiplication of their individual probability, okay, when they are statistically independent, then we can find their probability. Okay. Yes, I like that. Okay. Then P naught, this is Pi and so on, Pi, Pj, Pk up to Pm, mth, if there are mth sources are there. Okay. Then we can find their individual probability of the symbol at the final output. Okay. That is also joint at this point. Okay. Now, if we are knowing the probability of individual symbols, okay, we can calculate the entropy of this extended source. This is called the extended source or joint source or combined source. Okay. This is the extended source. Okay. Its probability can be calculated because whatever symbols coming at the output, we are knowing their individual probability. Okay. Then using the basic equation of the entropy, that is H equals to H extended, okay, this is equivalent to again probability extended log of base to 1 upon P e. Okay. You suppose this is there are n to the power m symbols, okay, then we can take it at I. Okay. Then I is equal to, here we can take, because I we have already taken, we can take L as a L, then L equals to 0 to n to the power m minus 1, total n to the power m symbols. Okay. Then this will be the entropy of the extended source. Okay. What happened? With some examples we will see that entropy of the extended source, this we can erase, entropy of the extended source H E, that is nothing but the its power was n to the power m, then m times probability of individual source, which is incorporated with that joint source, okay, that extended source. Hs is the basic source with its probability. Then entropy of the extended source can be calculated using this. and this can be proved also. Okay. That is very easy, and we will see with some examples also, that is how its probability can be calculated. Okay. Okay. We can take some examples. Suppose we are taking a source with their symbol S0, S1, S2, okay, and its probabilities P0, P1, P2. Okay. Here P0 equals to 1 by 4, P1 equals to 1 by 4, P2 equals to 1 by 2 suppose. Okay. We can calculate the entropy of this source Hs using the same formula, that is K equals to 0 to n minus 1 Pk log base 2 1 upon Pk. K is the 3 symbols, then K is equal to 0 to 2, 3 minus 1 2 Pk log base 2 1 upon Pk. Okay. And we are knowing the probability P0, P1, P2. Putting these values here, we can calculate the entropy of the source. Okay. This is 1 upon 4 log base 2 1 upon 4, that is the 4, plus 1 upon 4 log base 2 1 upon 4, that is the 4, plus 1 upon 2 log base 2 1 upon 2, that is the 2. Okay. If you calculate its value, it equals to 3 by 2 bits. This is the entropy of the source, 3 symbols and with their probability. Okay. And similarly, we can find entropy of its extended source with their suppose order m equals to 2, then S0, 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 S1 up to S2, S2. Okay. So that its probability P0, 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 P1 up to P2, P2. Okay. And if we calculate the entropy of this extended source He using this formula, okay, and it will be equivalent to 2 into 3 by 2, you will get equals to 3 bits. Okay. Then second order source, with taking this source as a basic source, then 2 sources at a time, then its entropy can be calculated, that is the 3 bits. Okay. This is the entropy of the extended source. Next lecture we will discuss relative entropy, okay, in next one. Okay. Thank you.